Welcome back. Now we're gonna talk about classes and object-oriented programming, and this is gonna be a little hard in the beginning, and we're not gonna use some of these things in this course, but it's very important that you know these things. We're not gonna go in too much detail in object-oriented programming, but we're definitely gonna know these concepts. So you gotta know how a class is made. If you don't know how inheritance works, it's all right, but I'm gonna show you these things now. So what are classes? Classes are just boxes. They help us define our own abstract type, like a dictionary is. But it's more flexible than a dictionary, way more flexible. Instead of just storing data, they also store functionalities. This combination of state and behavior is very useful because it lets us simulate the real world entities with code. So understanding classes is the basis for understanding object-oriented programming, which is used everywhere. So you will see classes everywhere, so buckle up and let's dive in. Now let's start with making a simple class. To make a class, there is a keyword called class keyword, and after this class keyword you have to write the name of the class. So let's say I'm making a car. Car is a real world entity. Now to make a car, you need to define an initializing function that initializes its state, right? I mean, what does a car have? It has gears, every car has a name, every car has miles, those numbers. So those are the states of a car. Now, how do we define that? We use an initialize function, exactly written the same way with 2 underscores on both sides. Now, what do we give to this? Well, first parameter that every method in a class is to be given is called a self parameter. A self tells us that what is in the class. For example, if whatever is here in the class, that's what self represents. So if I want to change anything in the class, I would change something in the self. Now this method has no access to it. That's why we have to pass self here. It's very important that you pass it. Just pass it every time. Don't even think about it. But you now know why that is important, and I'll show you in a second. Whenever you make an object of this class, and I will tell you what an object is. An object is the real world representation of this template of car that we are making in real life. And when we make this object, you have to understand that you're passing this name, gear, miles. Every car has its unique set of states, and so when you're dividing this function, we have to initialize our car's state to this name, gear, and miles. This class doesn't know what this actually means, so this self right here is representing this car, and this self's name will be equal to name, then self dot gear. Self's gear will be equal to that gear, and then self's miles will be replaced with miles. Pretty cool so far. Now we can define behavior for these classes as well using our own functions that we define for this class. Well, a car in real life can drive, it can shift gears. So I'm defining a real world entity. I can make a function called drive. Again, name whatever. Again, the self is always passed no matter what. This is always passed when you're defining a function for a class, because it has to have access. If you're doing something in a class, it has to have access to this thing right here, this context. And well, what do you need? You need miles here, and just like a normal function, self.miles will be equal to self.miles plus miles. Pretty simple stuff. You're just adding the miles to the previous one. Now let's begin by making another function called shift gear. And shift gear, same phenomena. Self is always passed no matter what happens, and gear is always passed. Like, what gear are you shifting to, man? So self.gear, I mean, it goes to the car, and I'm going to change my car's gear myself, self's gear, and that's why it's better to understand and make that intuition that way, and you will change the gear. Pretty cool so far. Now let's see this in action. Now we have made these instance variables, which instance variables are the instances of the class, the variables that are of the class that are made for every object that you made. Now this is just a type. Think of it as a data type. For example, a string. I can make its real object right here. I can make a new car, for example. Now I'm making a new car. Now when you call this function like this, like car, and you're giving it parameters like a function, you are calling this function actually, and you don't have to give self here. Self is automatically passed. You have to give these three. And Tesla, for example, let's say I take Tesla, how many gears? 5, let's say. Current gear would be 0, I guess. You can have 0 as the current gear, and miles would be 0. So pretty cool. We have made a new car that is the Tesla and has all these functionality. Now I can shift this gear and I can print the car dot gear. Let's see what happens. It's 0. Now what if I want to change it? I can call the shift gear method and set it to 6, let's say, and now it will change to 6. Now this is how you make changes in a car, and you can add as many functionality and state here that you want to add. Now to delete this object from memory, you can just call this function called delete, and this will delete the class altogether. If you access this, it won't be accessed. It should give you an error. Car is not defined. Now let's have some more fun and now talk about object-oriented programming. It's not necessary to understand this, but we will use we will not use advanced object-oriented programming concepts in this course because you're a beginner and you're still getting used to the syntax and programming. But it's good to know what inheritance is and what is just a few object-oriented concepts, and because object-oriented programming can really help you map the real-life objects to the code. And we're going to discuss inheritance. Inheritance is one of the ways you can arrange classes in object-oriented programming. So discussing inheritance, as the name suggests, helps us with inheriting stuff. And inheriting means, for example, in our car class, there would be some cars which have extra features, right? So you're making a new car and you're like, okay, there's some features that are different behavior, there's different state. So I can inherit some stuff that is in this class right here, but I also add more functionality on top of that, which is different for a Tesla, different for a Toyota, different for all different cars. They have different functionalities. You can add that on top of this car class, which is same for every car in the history. How do we do that? Pretty simple. I'm gonna take an example of an employee and manager. So a manager is also an employee, as we know that. So we have to make a class of employee that is just common everywhere. So a common class is called the parent class. Means all the functionalities are common in everything, everywhere you go. And a child class is the subclass which adds new functionalities, adds new state, adds new behavior. Now let's make a class of employee, right? And try to do this alongside. It helps. If I initialize here, I can see that there's a self is always passed. You have name, you have age, you have date of birth, job description, whatever you want to have. These are the instances that you have. This is the constructor that constructs your class. Now I can create this class very easily. The self is representing this class right here, and I can set the name and everything that has to be existed. The self.age is age, self.dob is dob, and self.job description is job description, which was passed into this constructor, by the way. Now you know how that works. Now I want to create some functionality that is common to everyone. Let's say get salary, which is not a function here, but I'm just showing you. It just prints stuff, you know. Salary printed. There is no state called salary. I'm just showing you to prove a concept. Now I want to create a child class. Child class is pretty simple. Manager is our child class. I name it manager, but I'm extending to everything that is in employee class. How do I do that? Well, instead of just writing this right here like this, I have to pass this employee class like that here, and now it's inheriting everything in it. So how do I define a constructor that initializes this class? Is by creating an initialize method that takes itself, all that stuff that this takes, 100% all of that, and some of the additional functionality. For example, department, employees under that person, and then you define this. And here is the tricky part. Now super is a keyword. Super accesses the parent. Super, when you call it, it's gonna access this employee right here, and it has access to all of this thing right here. So I want to initialize this. Very simple. I just call the initialize method of its parent, and I just pass all of this thing, all of these things that are required here. It's almost like doing the thing that we did here, but instead of doing it openly, which is doing this in this initializer method, and all others that are local to the manager, which are specific to the manager, are here. The department that manager is ruling, the employees that are under him or her. Pretty simple stuff, but you don't have to understand this. Now I can add on top of it a lot of functionality, you know, add employee, now let's see what happens if we create an object. You know, let's create a manager with name Kim, let's say 28 years old, whatever date is a string here, and you can manages. Again, don't be confused if that the current date doesn't make its age. It doesn't matter. Manages everything, and is from the engineering department. Manages the engineering department, and has 87 employees under it. Now let's see and call the get salary method. Salary printed. Cool. I want to show you something called method overriding. Method overriding is when there's the same method, get salary method, for employee, but I want to have a different method for manager. So I define this here anyway. Salary printed for manager. And this will be overridden. Now you don't have to know this stuff, of course, but I have to tell you, because if you want to go into object-oriented programming in studying later, you have to know this stuff. So this is all for, again, you can do manager dot get salary and it'll work just fine. Add employee and it'll work just fine. Not a problem. But you don't have to know this. You don't have to be good at it, but I'm teaching you for a reason, that you have to be very comfortable working with at least this, making cars. Now, as an exercise or as practice, just map your real world objects to this, to classes. And I'll see you in the next lecture.